Given the task of reducing RM's carbon footprint, we decided to focus on the inefficient bus routes, exploring the school bus's carbon emissions and its effect on our environment. We will analyze 2 bus routes and recreate them to increase efficiency and mitigate carbon emissions.
First, we will highlight the health implications caused by excess carbon emissions. Poisonous gases such as carbon monoxide emitted by school buses could be fatal to children exposed to it for a period of time. Diesel particulate matters, or DPM, is a complex and unhealthy mixture of inorganic and organic carbon particles with adhered toxins. DPM reduces lung function, aggravates asthma and allergies, increases respiratory infections, and risks of heart disease and lung disease. Ultimately, increased health risks could lead to more absences from school, emergency room visits, and possibly even premature death.
The increase in carbon emissions from buses also negatively impacts our atmosphere through the buildup of greenhouse gases. The Earth's mean average temperature is regulated by a steady equilibrium, which exists between the energy reaching the Earth from the Sun and the energy reflected by the Earth back into space. The incoming radiation is composed of short ultraviolet and visible radiation. Some of this radiation will be absorbed by the atmosphere and some of it will be reflected back from the Earth's surface into space. The radiation that is reflected back into space is infrared radiation, which has a longer wavelength.
Greenhouse gases such as carbon dioxide, methane, and oxides of nitrogen are less transparent to heat than light, so they absorb some of the reflected infrared radiation and re-reflect it back towards the Earth. This is what causes the greenhouse effect and results in an increase in average temperature on Earth. Although this process is a natural phenomenon, since there has been an increase in the greenhouse gases in the past century, this has resulted to an increase of the greenhouse effect, leading to higher than normal average temperatures, which could lead to disastrous consequences in the future.
Our independent variable is time with respect to distance traveled. Our assumption is that as the time it takes to travel each route increases, our dependent variable, which is the amount of carbon emissions, will increase as well. Our first case concerns 3 Richard Montgomery school buses that each only have 1 stop. Their stops are a mere 23 seconds and 2 minutes apart from each other according to Google Maps. We have collected data showing the time traveled for each of these buses and have calculated that, in total, with 1 minute for stopping at each stop, it takes these buses a total of 21 minutes to reach Richard Montgomery. This is in addition to the plus or minus 1 minute we have attributed for Google Maps error. Again, our assumption for all of these cases is that a longer travel time is synonymous with more carbon emissions.
This data table shows that when all 3 stops are gone to by 1 bus, the travel time decreases dramatically. From 21 minutes to 10 minutes, we have reduced the travel time by 11 minutes. This will mean that the carbon emitted has also been reduced dramatically.
Our second case concerns 1 Richard Montgomery school bus that has 5 stops about 0.3 miles or about a 3-minute walk from each other according to Google Maps. We have collected data showing that the time traveled for this bus and have calculated that in total, with 1 minute for stopping at each stop, it takes this bus a total of 16 minutes to reach Richard Montgomery.
This data table shows that when all the 5 bus stops are reduced to 2 bus stops, the travel time decreases dramatically. From 16 minutes to 12 minutes, we have reduced the travel time by 4 minutes. This will mean that the carbon emitted has also been reduced dramatically.
One weakness to our procedure is that our data on the total time it takes to travel each route was taken from Google Maps. Thus, technically, our data comes from a simulation and not actual trials taken from actual experience. Limitations on time make it impractical for us to ride each of the buses and time them for multiple tries of data. Not performing actual trials for the data and taking the average of those trials is one of our limitations. Also, we could not procure enough information on the number of students per stop, how big the buses were, and how weight affects the time it takes a bus to travel its route. This limits the scope of our results because we did not factor in all of these variables. Hence, one improvement would be a time extension for the project. Then we could actually go to each bus stop in the morning and time the total time traveled. We could get multiple trials, count the number of students per bus, and procure more detailed information regarding each route and the types of buses used, making our results more comprehensive.
In conclusion, our research has shown that if Richard Montgomery were to adjust its bus routes, we would reduce carbon emissions greatly. Therefore, we would decrease the amount of released diesel particulate matters that greatly affect human health. Our students would be safer and healthier. Although science and technology can improve our quality of life, unfortunately, they can also negatively impact our environment and our lives. It is also imperative to consider the social implications of changing bus routes. Finding routes to reduce carbon emissions can cause changes in the daily routines of the families of students. For example, students may have to wake up and arrive home earlier or later due to changes in the busing routes. On the one hand, this may cause schedule conflicts among some parents who have to go to work, or students who have extracurricular activities before and after school. On the other hand, this may also be more convenient for parents and students, as well as depending on their schedules.
School buses benefit students who live far from their schools but produce excess carbon emissions that could accumulate to have disastrous effects. In order to prevent any possible environmental issues caused by excessive carbon emissions, it is essential to make measures to prevent rather than cure, because money spent on preventative measures is not wasting money. It is investing in sustaining a better future. It's unjust for people that are not creating or contributing to the problem, for example, future humans, to suffer the effects of pollution.